Let's now talk about stuff. Before we resume the discussion about object equality, I'd like to, just as usual, remind you about several things for the course. And as I mentioned earlier, your programming test number 1 is just being finalized. I should be able to give you the result and feedback next Monday, the latest. If I can get it earlier, I'll definitely get it earlier. Okay, I'll keep you posted. All right, your lab number 2 is due this Friday, and make sure you submit by the deadline. And for your programming test number 2, it will be next Wednesday, not tomorrow, but next Wednesday. Let's take a look at the course calendar to see where we are. Guys, please. I know you guys are excited to come back, but we want to concentrate. Alrighty. Let's now take a look at the course calendar. Okay, you want to make sure you refresh your browser because I made some slight modification as I communicated to you during the reading week. So today we are here, lecture number 12. And today I'm hoping to finish another big chunk of the object equality. I should be able to finish that on Thursday, and I'm going to start a new topic related to aggregation and composition. Hopefully that one there wouldn't take too long. I'm quite confident next week, Tuesday, maybe the second half, we can start talking about inheritance. So that will be the most important topic, I believe, for the course. But we have paved the way all the way to understand about inheritance. Everything we have said so far in the course is going to help understanding inheritance. And don't forget, your programming test number 2 will be next week. And I already released a PDF guide for you for programming test number 2. Please take a look. And then if you got any question about it, let me know. All right, any question about the course in general? We good? Okay. So, and let's do a little bit of wrap up from 2 weeks ago, before the reading week. Let's now make sure you're on the same page, and then we should talk about some stuff that's going to build on top of what we learned before the reading week. Let's do some recap. So if you recall, on the Thursday before the reading week, we started talking about the equals method. You can see that the equals method will be available to be invoked even if the class itself does not have any explicit declaration of the equals method. That's simply because in the object class in Java, it has the equals method there by default. So you can always use it if there's no explicit overriding in your class about the equals method. That's the discussion we started before the reading week. And then we went on to give you more details. So this will be the diagram you really want to have in your mind. You want to think about, there is this object class that's already there. I cannot change it. And they have the default version of the equals method. And it will always, by default, compare the so-called reference equality, meaning that it's going to compare the addresses between the two objects. That's something we also showed to you last time. And we're going to go a little bit further from there to say, what if I want to have my customized version of the equals method? So always think about whenever you're declaring your class in the model package, it can either be that your class does not explicitly override the equals method. In that case, whenever you want to call the equals method on your objects, it's going to use the object version over here. Case number 2. Let's say in your class, which is going to be most of the cases, for example, your lab number 3 and also your future programming test, not programming test 2, but maybe 3. So the equals method, once you have explicitly overridden it in your class, that version is going to be called. And the default version is going to be ignored. All right, so that's really the mental picture you want to have. Either your model class will fall into this category without any default version, with the default version to be used. Or it might fall into this category where you have to use your own version of the equals method. And we went ahead to talk about the different cases. For example, in the case where we got point v1, which has not overridden the equals method. In that case, it will simply boil down into equals equals, right? The tracing that we did before the reading week, you may want to revisit that if you still have doubts. And one more detail I want to draw your attention. Before the reading week, we also spoke about when we say P1 dot equals some object over here, let's say the P1, which corresponds to point V1, that one does not have the overridden version for the equals. And we said this guy here is simply going to boil down into P1 equals S. However, I put it into double quotes, meaning that if you simply write P1 equals S directly on Eclipse, it's going to give you compilation error because the types are not compatible. However, the way you want to think about P1 dot equals S, in this case, it will be as if we did this. Right? You may want to review this part. This part can easily appear in the assessment. Right? If you got trouble understanding this, go back to the lecture before the reading week or reach out to me. Either way works. And we talk about the overridden version. That's what the discussion we started. And if you look at the equals method here, line number 1, 2, and 3 over here are pretty much standard. Normally, you don't really have any variation to it. You simply just follow. That's the standard way. What can really show your creativity or the specific details for your application would be phase number 4, which we're going to focus more today. But let's take a quick look on phase number 1, 2, and 3 very quickly. So phase number 1, we want to make sure the context objects, if it is the same object as obj, which is a parameter. In that case, the same object. So of course they're equal. That's case number 1. Phase number 2, if the obj that we are talking about as a parameter is actually null. We said about logically it doesn't make sense if this also happened to be null. Because if that was the case, we would have got null pointer exception even before we execute the body of the equals method. Right? So that's case number 2. And phase number 3 is basically how we start what we started and left off from Thursday. And the way I try to prepare you guys to understand this line, which we're going to talk about in just a moment, is by considering this particular exercise here. Right? That's also something I kind of reached out to you yesterday about. That's something you also want to review. If you haven't, you may want to do it soon. So in this exercise here, we talk about static type, dynamic type, and typecasting. All right? Quick review. Static type, very straightforward. Whenever you declare some variable, the type you declare that to be is a static type. That's it. Never changes. On the other hand, whenever you're doing tracing of the reassignment, for example, let's say I got O3 over here with the static type objects. But I might say O3 is reassigned to O1. I might later say O3 is reassigned to O2. I might do reassignment for as many times as I like. Now, if I say O3 is reassigned to O1, that means the dynamic type for O3 is now changed to C1. On the other hand, if I say O3 is reassigned to O2, and now O3 will be pointed here, and dynamic type has now become C2. Right? So dynamic type can always change whenever you do reassignments. That's also what we said earlier. Another thing that's so important about static type is as follows. Static type tells you the range of methods you can actually invoke on the context objects. For example, if you look at O1.m1, O1 was declared to be C1. So C1 is a static type for O1. Now, it tells you that you can only invoke the method on O1 that's defined in C1. In this case, only M1. Now, that's why when you say O1 to M1, that will compile. If you say O1 to M2, but M2 does not belong to C1. It only belongs to C2. So that's why it's a different class. So it doesn't compile over here. Right, so we try different combinations in that exercise before we enter the reading week. Right? And final point. Let's say over here, why is casting necessary? Let's say we talk about this O3 over here. O3, let's say currently it is pointing to an object that's dynamically C2. And in C2, we know that it should really have M2 defined. However, according to the rule I just reviewed, because O3 was declared to be static type objects, we cannot actually call M2 because static type restrict us to do so. The only way around is to do something called typecasting, which is over here. Okay? This one is saying I'm going to cast O3 over here, sorry. this one here. I'm going to cast O3 into C2. What that does, effectively, we are not creating any new objects. We still have just this object here. But instead, we're going to create an alias over here that's pointing to just the same objects. And then this one here is going to have the static type C2, which will allow us to call M2. Right? I'm just doing this a little bit fast because we kind of did that already thoroughly before the reading week. All right, so far, is there any question? Any details you want me to repeat? Go ahead.
Is the alias like just a label that's attached to the object, or is it like a temporary object?
Okay, so alias you can think about is like a temporary variable. So you can think about, okay, that's good. Good question here. You can think of this way. If I'm writing this way here, you can think about this expression here is more like an anonymous objects, that's alias. As soon as we are leaving the method that's being executed, it's going to be discarded. But what we're going to see in the equals method, we do have some name variable to save that address. So it might be kept a little bit longer. We'll see, yeah. All right, guys, any question? So I would say this exercise here, in some way, what I said before the reading week was it covered about 80% of what you're supposed to know about the types. There will still be 20% of the gap we need to fill out once we start talking about inheritance. But I think let's focus more on the example that's being illustrated here. That's enough for you to understand the equals method. Question, please.
So if you use a method like getClass for, let's say, O3 right there,
Yep.
It's going to return the static type.
Dynamic type. Okay, so your classmate is getting a little bit ahead. So as you can see in the equals method, you will see something called getClass over here. That's something I will redo again. Okay, how about we do that? Okay, getClass over here is going to return the dynamic type. Okay, so what we can do, how about this? Let me redo this one here just for this example here, to be very clear. Okay, so now we can gradually dive into today's contents. But before that, let me just say one more thing. Okay, the same example. And can we please focus on these lines? Line number 1, and also line number 2, and also line number 3. Okay, I'm only going to focus on these 3 lines. Okay, let's try that. And of course, before that, we know we already got O1 and O2. O1 and O2, so let's draw that. O1 is pointing to some C1 objects. And O2 is pointing to some C2 objects. All right, so now let's try that. So now I say object O3. O3 is going to point to wherever O1 is pointing to. So O3 now is going to point to wherever O1 is pointing to. Let's say after this line here, star. After that, if I say O3 dot getClass, this is something you will see in the equals method. Okay? We don't really have to understand exactly the return value. It's a class called class in Java, but we don't need to be bothered too much by its detail. I would say the only thing you got to understand is this method call here is going to return the dynamic type for O3. So this one here is going to return the dynamic type of the context object O3. And we know that this one should be C1 at this point. Don't forget, dynamic type can change as often as you like, but static type always remain the same once you have declared that. All right, let's now move on. And let's say I go for the next line here. How about this line here? I go here, and then I say O3, rather than pointing to here, it's now going to point to wherever O2 is pointing to. So now it's going to point to here. Oh, sorry, like that. And then let me put star star over here. After executing this line for reassignments, what's going to happen if I try O3 dot get class? Again, it's going to return the dynamic type of O3, which now should become C2. I think that answered your question, right? Very good. Let me say one more thing. That's more like a look ahead. Later on, we're going to see another operator in Java that's got to be a little bit more handy than get class is something called instance of. You may have heard of it maybe from the first year, but that's okay. That's something we'll see in much detail when we talk about inheritance. But for now, I'll just write it down later. Instance of. So once we get to that operator later in the lecture, when we talk about inheritance, you will see that that's kind of linked to this particular example. All right, any question? All right, let's now do a little bit tracing. Okay. So let's now get to phase number 3. Okay, phase number 3 is over here. So what is this saying? This one's saying if the dynamic type for, if the dynamic type for this, let me reconnect my pencil. There we go. Okay. If the dynamic type for this is not the same as the dynamic type for OBJ, and recall yourself, OBJ is the parameter. So we are saying that if these two objects, this and OBJ, they have different dynamic types. In that case, we are comparing apple with orange. No comparison, just return false. Visually speaking, what we are saying is like this. This is the context object. It's pointing to some objects at the runtime, and then its dynamic type, the title could be maybe triangle. And then we got also OBJ, the parameter. That one there is also pointing to another object over there. Let's say it's a star. Okay, different dynamic types, right? Could be the same, could be different. And what this if branch is saying that is, this .get class is going to give you the triangle. Obj.get class is going to give you the star. We're asking if this and this are different classes. In that way, we're comparing orange with apple. In that way, you got to return false. Otherwise, if this, maybe both of them are point V1, or maybe both of them are point V2, in that case, you can go further to execute the equals method. All right? That will be something I'll just write very quickly, and then we can see some example. If the two objects have distinct dynamic types, no comparison. In that way, just return false. That's really the logic here. For example, if you're comparing a point with a string, right? Let's see one example for tracing. I believe I got, okay, just one example. Okay, let's see. All right, let's now focus on line number 9 here. Line number 9, let's remind what we have. We got P1, and P1 was created earlier over here, has 2 and 3. And also we got another string S was created right here. So that's just another object. So we can think about S is basically another object over here, and that one there is simply just 2, 3. Okay, like that. Okay. Now, what's going to happen when you say P1 dot equals S? First of all, you want to know which version of the equals method is it going to execute. P1 dot equals S. And the principle, again, is going to look at the dynamic type. Dynamic type of this context object is the title of the box, point V2. That means invoke the version of equals from point V2. So this decision-making procedure is very important, right? Let me say it again. Whenever you have a method call, in this case, the equals method, in general, there are two possibilities. It could be the equals method from the object class, or it could be the equals method from the particular class that you're defining yourself. How do we decide? You want to look at the context objects, in this case P1. Look at its dynamic type, meaning what's really the object that's being dynamically pointed to by P1, in this case point V2. So you go back to point V2, do we have a version of the equals method here? Yes, we do, exactly here. That's why we are executing just this version without having to go back to this version here. We don't. That's a very important first step, because if you go to the wrong version, then everything else follows will be wrong. All right? So after this, we're going to execute this line by line. It would be an exercise for you to convince yourself. The first two lines, the if branches will just evaluate to false. Specifically for this condition here and for this condition here, both of them should evaluate to false. Otherwise, we would have returned true or false already, but we are not. Right? That's something we did last week, before the reading week. That's something I'll leave to you. So in this case, we're going to go into this line. Let me highlight it. Okay, this line here. This is the line that we're going to execute here. All right? So for this line here, what's going to happen? What you want to see is this over here is really corresponding to P1. Right? And OBJ over here is really corresponding to the parameter. And what's OBJ? S. All right, so that one there is S dot get class. And what are they individually? So P1 dot get class, P1 dot get class is going to give you point V2. And what about S dot get class? Well, S is simply a string. That one is going to give you string. So now you're basically saying, is this equal to this? They are not equal to. In that way, it's going to make, remember here the operators say they are not equal to each other. Now, they are not equal to each other because one is point V2, the other one is string. So if they are not equal to each other, so we're going to return false. So this is the result. Because point V2 not equal to string. Again, we're comparing dynamic types only here. All right, any question about this? Of course, I'm relying on you guys to kind of still have the understanding from the example that we did before the reading week. If you need to catch up, do it soon. All right? Any question I can answer now? We're going to still see more like this when we get to the phase number 4. All right? Everybody's good? All right, let's now move on to the last phase, which is not too bad. Okay, phase number 4, let's now do a little bit warm up here. So logically speaking, let me just make sure you kind of understand what I'm trying to say. If I got something like if some condition over here, if that's true, I'm going to return something. Let's say I got another condition here. Let me make it a little bit more logical. I got some Boolean condition, let's say B1. I got another condition B2 over here. Return something. And then in the third line, let's say I try to execute some line. And of course, the execution flow is going to start from the top all the way to the bottom, right? So here is something we want to observe to ourselves. Let's say I'm now at the runtime, and I'm telling you that I am able to reach this particular line. What does it really mean? Right? It means that we did not return here. we also did not return here. That's why we were able to reach here. I didn't really return from here. That means this Boolean condition must be false. Similarly, this Boolean condition must be false as well. So it should be not too bad for you to convince yourself being able to reach this line. We know that not B1 and not B2, logically speaking. Or if you want to play with De Morgan, you can say not the case B1 or B2. All right? If you're not too comfortable with the second one, that's okay for now. How about just the first one? All right? My point is, if we are able to reach this particular line, then we know that at this point, B1 cannot be true. B2 also cannot be true. That's basically what I'm saying. And why is this relevant? Let's go here. We got exactly this pattern here. If I'm able to talk about phase number 4, that means I didn't return true here. I didn't return false over here. I also didn't return false over here. So there are 3 things I know for sure at this point, and it's worth our time talking about them. All right? So what I want to do is, let's now make some observation. If I'm able to reach this point, so there are 3 things I know. All right? Number 1, I know that this is not equal to objects. They are different objects. Right? They are different objects. If they're the same objects, I would have returned true. Number 2, I know that obj is not equal to null. Because if you recall, there was also some discussion we made earlier. Let me mention that verbally quickly. We said that if obj is equal to null, and we know that this cannot be null, otherwise we would have got null pointer exception. If this is not equal to null, and obj is equal to null, then we should return false. That's something I said earlier in the reading week. But now we say that if this one was not really executed, so that means obj cannot be null. All right? So that's why I'm putting that here. All right, the final one, which is fresh. If we are able to avoid return false right here, that means this guy here and this guy here, the dynamic type must be equal. That means we're really comparing apple with apple. But whether these 2 apples are really the same apple, we don't know yet. That's why we need phase number 4. All right? Okay, so number 3 will be this and obj have the same dynamic type. All right, so these are the 3 things we know. And I think that this is really important for you to understand. All right? Everything's logical here. Okay, so now what about phase number 4? All right? So now you can see we're doing something that we learned earlier. We're doing some typecasting. But let's now try to review. Why is typecasting necessary? All right? What I want to do is, let's now visualize what's happening over here. Okay? So we got this. This is a context object. And this should really correspond to the type of the current class, right? That's where the class where we're defining the equals method. So this dynamically is pointing to some point v2 objects. And we know that obj dynamically is also pointing to some point v2 object, right? That's based on point number 3. And then that one there is also point v2. And we know that they are different objects based on point number 1. Right? You know, see, everything's logical here. That's why we can visualize it. Now, here's a question for you. If I know this and obj, they are both pointing to some point v2 objects, why can I not compare them directly? What do I mean? I'm going to write something here, and you can criticize it or you can agree with it. Let's say over here, star. I'm going to put it here. I'm going to say, rather than doing the typecasting, I'm going to do the following. I'm going to return something right away. I'm going to say return, and then I would say this dot x equals. So now rather than having some variable that's a result of the cast, I'm going to get rid of that variable. I will just say obj. I'm just going to use the obj here. And this dot y equals obj dot y. This is something I would like to ask you about. Can I replace the yellow by the orange? Can I or can I not? That's a question. Anybody?
You can't because you don't know for sure if the static type of OBJ is 0.2.
Actually, to be more certain, we know it is not .v2. We pretty much know, right? So I think your classmate was almost correct. Anybody want to speak up a bit? Almost. Okay, if no, let me speak up for this. Yeah, oh, sorry, go ahead.
So since we are like on the equals method, we are like getting an object. So even though if the method is like passing the object, then after we're getting basically we're doing a cast to a basic object. So then for sure we need to like have a casting methods to
Yes, I think I'm on the right track for sure. But let me put it slightly like a slower version for your classmate, right? I want to make sure everybody can kind of follow. All right, guys. Number one, this one here is not going to work. Even though I know what you're doing, but it just wouldn't work. You're going to get compilation error in Eclipse. Give it a try and convince yourself. Otherwise, I might put something similar to this in the written test too. All right, please try. So why would it not work? Number one, let's now take a look at the parameter. As soon as we see the declaration of obj, the parameter, we know that static type of obj is objects. And once we know about its static type, we know the range of methods that we can call on obj, which is only defined in the object class. All right? So the consequence of this is we can only call object attributes or methods on obj. That's the most important thing you should know about static type. Right? Static type determines about the range of attributes or methods you can invoke on that particular variable as the context objects. All right? So if, oh, sorry about that. There we go. Knowing this, now can this compile? Now it should be pretty clear it's not going to compile because obj over here, the static type again is objects. Does object class declare X? No. So that's why it's not going to compile. Similarly, this is also not going to compile. All right, this is very important for you to get right first. Otherwise, you might be keep asking yourself, why am I have to do the typecasting? I'm explaining to you, without the typecasting, that's why you will end up having compilation error. All right, now, if we really wanted the typecasting, how can we do it? So the way to think about it is like this. You can see obj dynamically is really pointing to .v2 objects, which should have both the x and y that I can invoke upon. So it should be possible. Somehow the only one that's not happy is the compiler. There is a way to trick or convince the compiler, which is typecasting. So what we do is something like here. Let me do this one here. So this guy here, typecasting. This one here is going to create not a new object. We're not creating any new objects. What we're doing is we're creating something like an alias. We're creating a new variable. We're creating basically something that's going to point to just the same objects that obj is pointing to. The only difference is now this alias here is going to have the same static type. Alias of static type point v2. All right, so this is going to be of static type point v2. This is the static type. And what's more, we can now store this particular alias to let it have a name, which is other. So that's why we'll see other here. So what we really have is this line here. So this line here is really corresponding to this particular alias that we're creating. So this is something you want to know. Any question? Yes? Of course. The static type for which two?
For other, like, because you know how we're doing that line, V2 other equals the point V2 object?
Yep, yep.
But we're doing that because the static types are different, right?
Okay, I see what you mean. Put it in this way. If you, let's say we don't have this part here. Let's say we don't have the typecast. OBJ by itself has only the static type objects. And we know that objects cannot be invoked, like obj.x, obj.y. That's not possible. So that's why instead of just using obj to access this object here, we try to create another alias which will allow us to get access to these objects. The reason that it will allow us to access is because its now static type can be created using the typecasting notation. So that one is creating this alias which has a different static type, point v2. That's what we're doing. Yeah, exactly. So the reason that we actually got this one here rather than point v2, right? Maybe that's your question. Good question here. The reason is in the object class, at this point, we simply don't know what kind of subclasses we might have. We might get point v2, we might get log, we might get refurbished shop, we got many other classes. So it's really difficult to put something very specific here in the object class. So what we do instead is to put objects, which is to say, whenever you want to compare yourself with something else, that something else can be just anything. Let's make it more general. Yeah. So because we're making the argument more general, we have to be more specific when we try to do the comparison. That's why. Good. All right, guys, one more time, if you bear with me. This line here is the most important line. Number one, if you don't have the typecast, you cannot say obj.x, obj.y. It's not going to compile because of its static type being objects. Number two, once you have done the typecast over here, you're not creating any new objects. You're basically creating just a new pointer. That's the same as obj, except that pointer there has a static type corresponding to the casting type, which is point v2. That way, once you have that pointer, like other, you will be able to say other.x and other.y. Because other, you can see, has the static type v2. Right? That's really the point you want to kind of understand gradually. Question?
Sorry, I have two questions. So first one, does that mean that any reference object that we create, it's also implicitly of static type object?
It's a good question here. I would say, how about this? The first question here, I would love to answer that, but I'll wait until we talk about the next small topic after object equality, which is call by value. How about it? Let me revisit this point when we get there.
Okay.
Question two.
The second question would be, will it also be possible to do anonymous objects to skip the line in green?
Yes, yes, that's a good question. That's a fair question. So what we could have done is this, using anonymous objects. So let me put another alternative version for you guys. How about this? So now this block over here, let's say star star. Alternatively, I can do something like, I can say point v2. That's a class tag, cast type, and obj. All right? And now you want to be careful. If you only put .x over here, it's still not going to work because the precedence of the operator is important. If you only put this, the Java compiler is going to treat it like this. You want to do obj.x and then cast the result value to this type. which is not what you want. All right? That's a subtle point. So what you really wanted to do is something like brackets over here dot x. All right? And this one here, you can say that one equals this dot x. And you can do the other part. Right? You see my point here. Right? So you can definitely do anonymous object. However, I wouldn't recommend anonymous object in general at this phase too much. Because normally, I think that this class over here, only x and y, easy to compare. But later on, when we see the more complicated example, you might have so many attributes you want to compare. Sometimes you might even require a loop. In that way, you have to repeat the same anonymous object cast in so many places. So why not store that in a variable like other and refer to it, right? So that's some design issue you can look after. All right, guys, any more questions? All right, take some time to digest. All right, so that's good. And let's now do some quick tracing together. So now that we got phase number 4, so I think I got 2 examples to do the tracing together. Okay, let's see. Number 1, we only focus on line number 10 here, in which case we're going to involve P1 and also P2. So P1 was created over here, and P2 was created over here. So P1 has 2 and 3. P2 also has 2 and 3. And now again, you want to really know what's the dynamic type of P1. Dynamic type of P1, you can easily see that it's point V2. So that means we're going to invoke the version of the equals in point V2. Right? Again, that's the same decision procedure. Right? You want to keep doing it. And don't worry, I'm going to repeat this principle almost 100 times when I talk about inheritance. Right? We're going to keep emphasizing. Because there will be situations where you have to look at the static type. There will be situations you have to look at the dynamic type. It really depends. But there will be some principle to follow. For now, you just have to remember, in order to determine which version of the equals to really execute, you have to look at the dynamic type for the context objects. That's all you need to know for now. Okay. All right, so let's now execute this one here. And again, exercise, do it for yourself, not just for me. You can now try to convince yourself all these are going to evaluate to false for each of the if condition. So we're just going to reach this point here. Right? That's exercise for you. And let's now try to see what's happening here. So OBJ, in this case, is going to be P2. Right? You can see P2 here. And OBJ is actually P2. So we're just going to create an alias called other. So we're just going to create an alias over here. Other. And most importantly, other is going to be of type point V2, static type. So that's why we can now do this dot x and also other dot x. And let's now do some quick replacement. Because we're talking about P1 dot equal, so P1 is the this. And also we got P2 over here. So now, sorry. Other is actually here. We don't need the P2 anymore. So other is actually over here, right? Let's now try to do that quickly. So now P1.x, other.x, P1.x, other.x, 2 and 2, and also 3 and 3. So that should be true. They are same objects. They are not stored in the same location in the memory, but they have the same contents for x and y. That's why it should be true. And the next example shows to you, let's say we got P2 that equals P3. So now you can see P2. Okay, for this one, I don't need to repeat the tracing again, but I'll show you the essence you need to understand. P2 is here, and P3 is here. Different objects, but we got 2, 3, and 4, 6. 2, 3, and 4, 6. And again, we're going to reach this point over here. And then we're going to create that cast alias over here called other. And now it will boil down into this. And we are really going to compare this, which will be P2. So P2.x, and also, I think I created the wrong one. Beg your pardon. Let me see it again. You can see here we say equals P3 over here, right? So that means we should really create an alias to P3. I drew the wrong one. Again, my apology. So it should be here. Okay, that's what we should do, right? The same principle. So now, if we try to compare this one here, it's going to be this.x, other.x. So P2.x, other.x. So we're comparing 2 and 4. They are not the same. So we can reject it right away. So this one here would be false. If you try to put these two tracing examples side by side, what do we learn? What we are learning is when you're trying to compare apple with apple, apple with apple, the contents of the apple might be the same, in which case you return true, like in this case. In this case, we're comparing also apple with apple because point V2 and point V2. In that case, the contents happen to be not the same. In that case, this expression here is going to give you false. Right? So these are the two possible cases. All right, any question? Is there any point that's really bothering you? You should really speak up now. I don't mind repeating. Anyone? If you want to take more time, take your time. Alrighty, so that's about the 4 phases. And let's now do some recap before we talk about some follow-up stuff. So what we have seen so far, we got the object default equals. And we might got one class where we don't have the overridden version, in which case we use the default version. Or you might have a class like a point V2 where we do have the overridden version and we're just going to use it. In this case, we ignore this equals method, right? 2 cases. And these 2 pieces of code, we have already traced them thoroughly. Now, I want to draw your attention to 2 lines and compare them. Line number 10 and also line number 10. Okay, I want you to take a look at these 2. Especially, I want you to look at the context object here, P1 and P1 over here. The P1 above is corresponding to point V1. The P1 below is corresponding to point V2. That means the version of the equals method that's going to be invoked will be different. Agree? So now in this case over here, the default version will be invoked. Because in point V1, we don't have it. And for over here, the overridden version will be invoked in point V2. Right? That's important for you to do the comparison. All right? And for the star over here, we know that it will boil down into just P1 equals P2. They are not the same objects. So that's why it's going to be false. And for this one over here, P1 dot equals P2, indeed, they are different objects. However, the contents are the same, 2, 3 versus 2, 3. Right? So this one here, it will boil down into P1 dot equals P2, which by definition is going to compare their x and y. P1 dot x equals P1 dot y, and also what am I writing? P1 dot x, P2 dot x. And also P1 dot y equals P2 dot y. Right? So I'm saying that either we're comparing reference in this case, which will give us false, or we're comparing their contents over here. In that case, it's going to give us true. Right? So you really want to compare these two versions. Okay? Do the tracing and then really see the comparison. All right, any question about this? We good? Alrighty. And let's do a little bit of thinking here. Before that, let me give you some context here. If you go back to the slides, slide number 8, so this one here really summarizes about different phases over here, and we talked about them thoroughly already. And this is also the discussion about why this cannot be null. That's also something we said earlier. All right? All right, so that's about the typecasting line, phase number 4. You can also read the slides. Everything has been discussed as well. All right, so now let's talk about equality. Let's now summarize a little bit of what we have said so far. So there are two notions of equality. Either we got reference equality. In that case, just use the equals operator. In that case, we're just comparing the address of the objects. And there's another notion about object equality, meaning that if the default version of the equals method has been overridden in your particular class, in that way, if you call equals method, it's going to compare conceptually the contents of the objects. So that's what we meant by the object equality. All right, so here is some example for you. I'm going to do one line there with you, but before that, let me ask you a question here. Of course, you can see the answer, but the answer is not the important point. Here, I'm going to ask you this. All right, let's say this. Okay, so let's now talk about option A and B. All right, and you guys learned about logical implication, right, in your logic course, right? Let me remind you very quickly. We need a little bit of knowledge about that. If you recall, if I say P implies Q, or maybe what you learned was like a P implies Q, doesn't matter. Either a single line error or double line error, doesn't matter. P implies Q. So now, let's call this A and B, right? Now for A, when I say two objects are reference equal, what do I mean? I mean object number 1 equals object number 2. That's what I meant. That's the first proposition. And object 1 equals object 2 is going to give me true or false. And what about B? B is going to be another proposition which will give me either true or false. But when I say content equal, what I really meant was obj1 equals, sorry, not equals, beg your pardon. obj1 dot equals obj2. All right, A and B. Now, what I really want you to decide is like this. If I say obj1 equals obj2, that implies obj1 dot equals obj2. Or vice versa. obj1 dot equals obj2 implies obj1 equals obj2. And quickly remind, this is reference equality. And this one over here is object equality. And let's call this 1, and let's call this 2. We want to decide, is the implication here, what does this implication really mean? I'm saying that if I know that this is already true, can I conclude this is true as well? Similarly, if I know that this is already true, can I conclude that this is also true? Right? That's the meaning. Now, does this implication always hold for 1? And does this implication always hold for 2? Now, option for you. It's like a box, right? Now, which one would you take? Take the one that's going to always hold. Either 1 or 2 or both. I can tell you at least one of them is true, at least.
I think just the first one, because if they store the same address, then it's the same object, so the content should also be.
That one I definitely agree with you. So this one definitely a tick. That one's easy to justify. So now if I know that obj1 and obj2, they basically point to the same object here, it doesn't matter what attributes they have. When you compare them, you're comparing just itself, right? Conceptually, just the same. I agree. What about number 2 here? Should number 2 hold in general for the implication? If I know that 2 objects are of the same contents on their attributes, can I conclude that they are stored in the same place in the memory? Does it sound right? Okay? Yeah, maybe the way I phrase it, it already tell you the answer. Yeah, no, not really. Not in general. For example, if you have obj1, obj2, for example, let's say object here, different object here, but maybe their contents attribute value, maybe x and y are just the same, but they're different objects, right? Right, that's important. Okay, now let's see one more example. And for this example here, you should really try to trace the whole thing, but I will show you the one that you can look at. For example, this one here. These 2 lines. All right, for these 2 lines, you can see that over here, P1 and P2. P1 and P2, they are different objects. So this one here is going to give you false. Now I got P1 dot equals P2, and P1, I see its dynamic type, point V2. So that means it's going to compare contents over here. So that's going to be true. Now, if you recall the truth table of your implication, if I got true, which is object equality, right? When I'm talking about object equality here, implies false, which will be reference equality. And I know that that one is equivalent to false. All right? That one just justifies what we just said. And if you really are wondering, am I going to ask you about the truth table of implication in the exam? No. But I want to justify that, right? It's good for you to recall, to make some connection. All right, good. All right, the next topic should be about the J-unit assertions. And I would suggest, how about we take a very short break by taking attendance, and then we'll resume. All right, take a short break. If you can have your mobile device ready, and then let me pause the recording. All right, so now I would like to say one more thing about object equality before we move on to J-unit test. One more thing. So this is more like a design principle I'd like to briefly mention. It's part of the Java API. You can also read the Java documentation online if you want to, but I'm going to summarize the critical points over here. So this is to say, whenever you want to design your own equals method, which most likely you will do for lab number 3, then you have to follow certain principles. They're pretty straightforward. Okay? The first one might be a little bit trickier to read. So this one is to say, you want to make sure x dot equals null is always not the case. But you can see this symbol here means logical negation, right? So what I'm going to do is let me now explain that separately. This is the only trickier one. So that one is to say, not the case, x dot equals null. Right, so this one really tells you the following. X dot equals null should always evaluate to false. Because if that always evaluate to false, not false is going to give you true. So you still got like a theorem, right? But what does this really mean? That means we know that x over here cannot be null. Otherwise, you would have got null pointer exception. Given that x is not equal to null, then comparing something that's not null with null, you should always get false, right? That's what this requirement really means. Okay, because x cannot be null. Otherwise, null pointer exception. Right, so that's the only principle I'd like to say a little bit more, but that one's not too bad. And then you want to make sure every time you say x equals itself, that should always be true, right? Because you can see the reference comparison, x equals x should just be true. Also, symmetric, if you say x equals y, then y equals x should be true as well. You want to make sure that. And a little bit more generally, so if you say x equals y and y equals z, then x must equal to z, transitive, right? That all makes sense. But I would say typically, whenever you're trying to design your equals method, most likely you will satisfy all of them if you follow the standard way of defining things. But just in case, if you miss anything, always good to check. All right, hopefully that one's okay. And let's now talk about JUnits. Okay, so there are basically two assertions that we need to master. One is called assert the same. The other one is called assert equals. Okay, let's talk about them just on the notes, but you can also look at the slides. Everything's there. So the first one to talk about is called assert same. And this one here, really not much to say. You just have to remember assert the same over here is really about the same address. That's what that really means. So when you say assert the same, expression 1, expression 2, this will just boil down into expression 1 equals expression 2. All right? So there are two ways to interpret this. Assert the same, expression 1 followed by expression 2. It will be as if you want to make sure equals is going to give you true. And if they are the same objects, not equal to is going to give you false. That's why assert false will also pass. How about this? If I got expression 1 point to this object here, and expression 2 also point to the same objects, right? If you try to say assert the same, expression 1, expression 2, now it should pass. If I try assert true, expression 1, expression 2 equals. This is equal to that. Of course, it's also going to pass. On the other hand, if I try expression 1 not equal to expression 2, in this case, are they not the same objects? They're the same objects, right? So that's why here, expression 1 not equal to expression 2 is going to give you false. So that's why assert false is going to give you pass. Right? You just got to be a little bit twisting the logic. All right, that's good. And let's now do some very quick example. Let's say we got P1, P2, P3, right? So P1 is pointing to some new object here. P2 is pointing to just another new object. And P3 is just going to point to the same object as P1. As far as assert same is concerned, we don't have to worry about attributes. We don't need to worry about the contents. So what I drew here will be just enough. Now, the first one. Assert the same P1 and P3. Now, here's the thing. If you simply say true or false, it's not precisely correct to say. You want to say pass or fail. Because assertion, there's no true or false. It's only pass or fail, right? So now if I say assert the same, P1 and P3 should pass. Assert the same, P2, P3, you should fail, all right? Because they're different objects. That's about assert same, which is as easy as that. Okay, you just got to remember for assert the same, you don't have any complication about which version to really invoke because it's only just equals equals reference comparison you have to do. That's it. And let's now talk about assert equals. Okay, so there are three cases basically. Case number one, which you have already seen in your lab number 0 until now, right? So if you have expression 1, expression 2, if they're both primitive type, in that case, we are just going to compare their values only. Because you remember, equals method is not applicable for primitive type. Okay? So let's say we got I and j, both integers. Assert equals ij would be as if we actually said assert true. I equals j. And that one should fail because they are not the same. And if you like, you can also try to understand this. What if I say assert false? I not equal to j. This one's interesting, all right? Now, how do we judge whether that should pass or fail? Well, I here is 10. J here is 20. 10 not equal to 20 should be true. However, we are asserting false. So it's going to fail. All right? So we got consistent result here. All right? Alrighty. Let's now move on to the more interesting case. So now we got two more cases to talk about. So whenever you got assert equals, and now we know that expression 1, expression 2, they are reference type. Expression 1, expression 2. So they are reference type. So for this one here, let me talk about them separately because this is important. All right? So now we should really understand what it really boils down into for the expression. All right? So when you talk about this, assert equals. So we got expression 1, and also we got expression 2. And then our assumption is both of them are reference types, not primitive. And notice that I'm using plural here. That means they might be apple and orange. They don't need to be apple and apple, right? And this will boil down into expression 1 dot equals expression 2. This is the principle you have to remember. Whenever I say assert equals, where the two arguments there, expression 1, expression 2, are reference types. That will boil down into expression 1 dot equals expression 2. And let me emphasize here, the expression 1 here is the first argument, and expression 2 here is the second argument. The order matters. All right? And let me now elaborate that a little bit more. Two cases. If I say assert equals, and I'm going to put expression 1, expression 2. And case number 2, assert equals, but now this time I decided to swap the order. Expression 2, expression 1. All right? You might be thinking they will behave similarly. Not necessarily. All right? It depends on the dynamic type. All right? Let's see. By definition, this boils down into expression 1 dot equals expression 2. And this one boils down into expression 2 dot equals expression 1. And of course, the principle is the first argument corresponds to the context objects. And the second arguments correspond to the argument to the equals method, right? Hopefully you can see that. And let's say something more. Which version it is going to boil down into calling depends on the dynamic type of the context objects. So now, over here, this will actually invoke the equals method defined in expression 1's dynamic type. For example, if expression 1 is dynamically pointing to point V1, in that case, we call the default version. If the dynamic type for expression 1 is point V2, then we call the point V2 version. Agree? Symmetrically, this one here is going to invoke the equals method defined in expression 2 dynamic type, right? You can see here expression 1 versus expression 2, right? Because expression 1 is here, expression 2 is here. That's a subtle difference I want you to notice. When you do the tracing, first argument always determine which version we're going to call for the equals. Okay, let's do some example. All right, let's now take a look. So let's see here. Assert equals, and then we got P1, P2, right? So this boils down into P1 dot equals P2. And we know that P1 has the dynamic type point V1. So default version. So it will boil down into P1 equals P2, right? Default version. And now P1 equals P2 cannot be true because they are different objects. All right? And then similarly, if you do this one here, P2 and P3, similar. P2 and P3. So it will be P2 dot equals P3. And P2 dynamically is also point V1. So the same. Also boils down into P2 equals P3. And in this case, it's interesting. Okay? If you look at P2 and P3, P2 here and P3 over here, you can see, number one, they are simply different objects, right? Different new keywords. So this one here definitely is going to give you false. However, there is something that we also, I show you on the eclipse to show you that. Here, let me mention that very quickly. Writing P2 equals P3 directly causes compilation error. Because P2 and P3, they are of different types. But in this case, for the object equality over here, it's okay because P3 is supposed to be just an object. We can pass anything. So conceptually, you want to think about it will be as if we try to do something like a reference equality, right? That's also something we said before the reading week. So the second assertion you want to pay more attention to, right? Even though it's still going to give you the false when I say false, it's like a fail. Assert equals and assert equals, right? So when I say false here and false here, I really meant to say fail. Because assertion is not really true or false, either pass or fail. Okay, I think we can do one more. How about that? And for others, you can try to do as exercise. Why don't we try here? Okay, let's do this final one, and then that's it. All right? So now tell me pass or fail. P2, P3. Again, no true or false, pass or fail. Anybody? Let me remind you one thing here. P2, P3 over here seems to be of the same contents. So should I give you pass or fail? Please. Oh, take a guess. What's pass or fail? Fail? Yeah, it's going to fail. But why did it fail? Do you know? It's actually something to do with the different types, okay? Okay, guys, bear with me. How about 1 minute, if I may? So this one here is actually going to fail. However, this one here, it will end up invoke the equals in. How about this? Let me address this more properly. Let me continue from here on Thursday. Otherwise, you'll be too rushed. Okay, thank you so much. I'll see you on Thursday. I'll start from here again.